Boomers. Okay. All right. So we are going to talk about, I am already presenting, so we're good to go here. And I closed the lesson. That was not good. 4.3. Here's a story about 4.3. The story is this. The homework is hard. Okay. But we are reviewing on Thursday when I see you. I think we're going to be looking at like a 50%. Try to get like close to 40 or 50% on the homework. If the problem looks hard, I need you to skip it because I believe on Thursday I'm going to be working almost entirely on the homework. This will be fine for you because the review are all problems you have seen before, and there are only 20 questions or so on the review. So like going over the homework will still prepare you for the it'll still prepare you for your test. So spend your normal amount of time on homework, but understand that we are going to be doing quite a bit of this in class on Thursday. Not going to be doing the easy stuff, you know what I mean? And then the review. You'll also be reviewing on Friday as well. Okay? I would really like this to be a good test. And I will tell you, quite a few kids, I said PIDs, but then I changed it to kids. Quite a few kids did retake this test last year. But whenever I went over it with them, they're like, oh, it wasn't that hard. The problem is the problems are kind of consuming, like a lot of multiplying and foiling, which isn't necessarily hard. It's just annoying. Okay. So make sure you do the review. So maybe if you wanted to not even look at the homework and just look at the review tonight, whatever, but you need to start preparing for the test, what I'm telling you. Okay. Now is not the time not to do anything, but I also don't want you to be on the struggle bus. Okay. So work, but don't stress yourself out. Okay. So here's what we have. Theorems, theorems, theorems. Some important stuff. And some of you already know, but what is happening? Did you see that line at the bottom? Okay. Me neither. I guess you guys, Clark, can you still hear me? All right, just making sure. Like text Curtis, who's I guess not doing anything right now. He's not very busy. He's playing games. So he has his phone out and is clearly sitting right in front of my face without his notes out or anything. Like you can just text him if you can't hear me or there's technical difficulties. I'm guessing he'll let me know. Right. But it's fine. Okay. Okay, great. Fundamental theorem of algebra. This was taught to you in Algebra 2. And we actually use it more than we title it. Okay, here's what it says. The degree of a polynomial, I'm just going to say poly for polynomial, tells you the number of zeros you are looking for. Now, when I say looking for, I had a student email me last week and said, so we're really just supposed to use our calculator for all these problems? And I don't know if you watched the videos I made to help you with the 4.3 homework. I did really actually divide them all out synthetically like they told me to see if the remainder is 0. But the truth is, I didn't have to do that on any of them. I could have typed them into my y equals on the calculator and looked at the freaking table and see, is 5 a 0? Well, is 5 a 0? Like, look at your table. And the truth is, yes, you can just use your calculator. And you really should just use your calculator because there are times when you can't. And the times that you can't are very time consuming. Does that make sense? So if you save your time and do it correctly with the technology, then do it. But they want you to practice whenever they're easier numbers, like doing it by hand, because when they're more complicated, when you actually have to do it, you don't want to just start with the hard stuff type thing. Does that make sense? So when it's looking for zeros, the first thing you should do is go to your table. Go to your table and see, can I find any? You know how many you're looking for because the degree tells you. If the degree is 5, you're looking for 5. Now, do we always find 5? No, we like barely ever find 5. So that's why you have to realize what they look for. You're looking for x-intercepts. Those are the real ones. Okay. They could be x-intercepts real. Remember, multiplicity counts. What do I mean by that? And you don't have to write this down, but just remember, if I am looking for 3 and I only found 2 on my table and I was looking for 3, if you go to the graph and you see something that looks like this, I was looking for 3, I only found 2, there's definitely 1, right? Do you remember what this is, a bounce? The bounce is multiplicity 2. That one actually counts twice, okay? Bounces you could see on the graph, but not on the table. So if you're short, go ahead and look at the graph to see. Maybe one of them looked like that, or maybe you only found 1, but your graph looks just like this, because that's what multiplicity 3 looks like, a hesitation and then a pass through, right? But maybe you just didn't find enough, and that's going to happen because multiplicity counts, or you could have imaginary, which we also call complex. You can't see. You have to do by hand. You'll have to do those by hand. But you know how many you're looking for and how many answers you're going to find based on the degree. But I think everybody knew that. When I say the degree is 4, everybody should know you're looking for 4 answers here. Okay, we good with that? Awesome blossom. Okay, so this question will be on your homework and your test as well. It'll say this: find a poly or polynomial, degree 3, with zeros, 1, 3i, negative 3i. Now, we talked about this last week. It just seems like so long ago whenever I have you guys, like the last time where you teach. This is a crazy part about this every other day thing. I told you there would be a question on the test, and they would ask you to factor it and to find the zeros. And you will look at it, and it'll be an x to the third, and you're not going to know what to do, right? And I told you, go to your table, and you'll see that the zeros are at 2, 1, and negative 4. Well, if those are the zeros, how can you write an equation? What would the equation be? Perfect. X minus 2, x minus 1, x plus 4. So don't remember. Yesterday, this is a true fact. I just started waking up early again because the kids have started practice. So Jackson had practice at 6 a.m. So I'm like, this is perfect. I'm going to start exercising again in the morning. And like my brain is not completely awake. I told my first kid, I go, listen, you have to speak up. I'm like blind in my right ear. And like the kids like kept saying, you're blind in your right ear. I go, that's what I said. And I like kept correcting them on it. And they're like, you are stupid. I'm like, I am stupid. I'm so sorry. Remember, if you know zeros, you don't have to write this if you did remember, but a lot of kids do forget. You know the factors. So they told us the zero. So you're like, sweet niblets. The degree is 3. I'm looking for 3. Great news. They told me 3, right? I'm just going to write these factors. So what would the factors be? And then, which seems kind of stupid, and x plus 3i. Now, we don't usually leave things like that. That looks kind of stupid. And it is kind of stupid, but it is right. And you leave it this way. Now, if you view an example on your math lab, technically there could be a number in front like 2, and those zeros would still be the same thing, or 3 or 1/2, and it would still work. I'm obviously going to pick 1 and not put anything there because it's easier, right? And it says find a polynomial. So I choose 1. If you view an example, there is a possibility that they're going to put a letter in front like this, like A of K or sometimes they just put K or A sub N or something in front. Do not let that confuse you. They're just putting it there saying, if there was a number there, there could be, because somebody might have wanted to make the problem harder and pick a 2, and your answer would still be right. Does that make sense? Nobody do that, because that would be a very stupid thing to do. It's going to make it way harder. Okay, but this looks weird. It is technically factored form, but we don't factor that way. So we are going to clean this up. We're actually going to go all the way to standard form. How do you go from factored form to standard form? You FOIL, right? Especially for quadratics. And I love that you said that. Or double distribute, depending who your teacher was. Now, the thing is here, there's 3. So the first outer inner last doesn't really work unless you do 2 at a time, which is exactly what she would do. Unfortunately, we're little machines, and a lot of times we think left to right like we read. Never do that with these. Always, always, always multiply the weirdos first. Always multiply the weirdos first, especially when they're numbers like this. Do you remember how what these 2 terms are called, how they're related, what they're called? What? It will be the difference of 2 squares. And do you know what the names of the pairs are? There's something pairs. But you're right. That's the example I'm going to write down right now. You're reading my mind. Begins with a C. Conjugate pairs. Beautiful. Just a reminder. This is a reminder. You don't have to, but again, you're stupid if you don't. I should not call kids stupid. It's going to make your life. I did not call any. I didn't call anybody stupid. Owen, are we safe? Are we safe? Is it safe? Okay, it's safe. I didn't call anybody stupid. It would be a bad choice because it would make your life more difficult. I did not call you stupid. You don't even have your freaking phone. Oh, you do have your phone put away. Always multiply conjugates first if possible. And the reason being is this what Maddie said. Difference of 2 squares is our first experience with conjugate pairs, x plus 2 and x minus 2. When you FOIL them, the O and the I cancel out and it gets smaller. Do you know what I mean? It's x squared minus 4, right? When you multiply that, plus 2x minus 2x. So if I multiply these 2 first, I'm going to get something smaller or easier. So always do that first. Okay, now look what happens when we do that. Give myself some space. Okay, I get y equals x minus 1 because I'm going to hold on to that. X times x is x squared. Now, I really don't want to write this next part. Plus 3ix minus 3ix. Does everybody see that? Those cancel out. I'll go ahead and write it. This will be on your homework. These are good examples to write down. And then I get a minus 3i times positive 3i. That's 9i squared. What's minus 9i squared the same thing as? That's the same thing as plus 9. And these guys cancel, right? So this is the same thing as x minus 1 times x squared plus 9. So what does this tell me about this? This is what you guys would have called factored form. This is technically factored form. This is as well. One's called factored over the complex system. One's called factored over the reals. They're both technically right. But doesn't this look so much better? It looks so much better, right? And to write it in standard form, we just FOIL or double distribute one more time. X times x squared is x to the third. It's plus 9x, and then it's a minus 1x squared. I'm going to put the minus 1x squared first because I know I want it in standard form. And now put the plus 9x because I'm running out of space. Some of you would have taken 2 lines to do that, and I'm sorry for skipping a line there, but I just was running out of space. Okay, so now I just want to go back for 1 second to 4.3. 4.3 could have told me to factor this. Like we just went down the chart. We just went this way. 4.3 had us go this way. They gave you this equation. They said factor it. You should go to your graphing calculator and you look at the table. What am I going to find on the table? I'm going to find 1. Does everybody understand that? That's the only thing I'm going to find on the table. But I was looking for 3 things, and I only found 1. Does everybody understand that? So I have to find the rest. So you put 1 in the box, and you would synthetic divide. When I was done, I have a remainder of 0, and I would get x squared plus 0x plus 9, which is x squared plus 9. So that means this times this, because the remainder is 0, is the same thing as that. Is everyone good? Now, how do we find zeros? We use what's called the zero product property, which nobody ever remembers the name, but you've been doing this so long from factored form, you're all pretty darn good at it. Unfortunately, the way you have it memorized, a lot of you, doesn't help. You would have right away said, okay, one of the zeros is 1. And then you would have looked at this one, and you would have gone, all right, like, what do I do? Oh yeah, x squared plus 9 has to equal 0 if it's going to be an x-intercept. Well, how would I solve that? Subtract 9, square root both sides. Are you seeing it? That's where the plus or minus 3i came from. So this time they gave us the zeros and we went down, but before we were starting with the equation and finding the zeros. Okay, do you see how it's kind of all tying together? Okay, right. It's probably very exhilarating for all of you. Okay, so if you need to like take a break to like just appreciate the wonder of math, go ahead, and I encourage you to do that. Okay, there's a question just like this on your math lab. I just saw it, and I don't know what they're going to have you do, but if this was on my test, I might have had a different thing than them. Okay, so here's what it says. Find a poly. I'm going to say degree 5 poly with -1 as a 0, multiplicity 3, 4 as a 0, multiplicity 1, and 0 as a 0, multiplicity 1. Did every single person sign up for the Lewis and Clark thing then? Right? That's super important. I'm going to ask her for a list for that because there's stuff in it. No, actually, my water tastes really good today because I got a new water bottle. I think my old one might have had some mold in it. Tastes way better. I mean, I don't think it really had mold in it, but I wouldn't be surprised. Okay, we got that down? What did he say? Right. It's like penicillin. Right, basically. Okay, now, this question is also interesting because this question is from section 4.1. It's from 4.1, and it was on your final. Because remember, I did that one section that was covered on the final? And so this one is flipped upside down as well. Before, they gave us an equation and asked you for the zeros and the multiplicity. Now they're telling you the zeros and the multiplicity, and they're asking you for the equation. So if -1 is a 0, what do you know? If you know a 0, you know a factor, right? So if -1 is a 0, x plus 1 is a factor. Not only that, she remembered what the multiplicity means. The multiplicity says, hey, by the way, that's coming up 3 times, which on a graph would mean at -1, there would be a hesitation and then a pass through. Okay, 4 is a 0 of multiplicity 1. What's that mean? X minus 4, no exponent required, right? This is the one everyone struggles with, but you don't have to. If 0 is a 0, even if you have autopilot change the sign, then write it down this way if you need to, and then realize that's not right. Right? If 0 is a 0, what is the factor? Just x. Multiplicity 1 is an x in front. Once again, technically, because they're giving you freedom of choice, it says find a polynomial. You could put a number in front if you wanted to, but let's choose not to. Now, if this was my test and that question was on there, I would say this is good enough, kids. Let's leave it like that. Let's leave it in factored form. You have a question nearly identical to this on your math lab. I don't know what they want you to do. If they tell you your answer is right, but it's in the wrong form, I would not continue. Wait and ask me. Okay. Or you could view an example and scroll down to see. Because look, first of all, it is degree 5. X times x to the third times x. Does everybody see how it is x to the fifth? To get it in standard form, you need to understand what's going to have to happen. X times x plus 1 times x plus 1 times x plus 1 times x minus 4. Do you see? Some of you already hate me. Like, why would I fan that fire? I love math. I do it all day, every day. Math, 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 math. This is not enjoyable to me. Do you know what I mean? It's just busy. This is just busy work. Sure, I could multiply these two. Where's my cursor friend? There it goes. And get x squared plus x. And then I could multiply it by these two, which I've done a lot of those, so I'm pretty fast at it. X squared plus x plus 2x plus 1 times x minus 4. But then I have to multiply these, get that, and then multiply it by that. Pass, right? So if it's much more than degree 4, I think you should be able to do it through degree 4. But if they're asking for degree 5, go ahead and leave it factored and don't spend time on it, and we'll see what they want us to do. Okay? Or I'll double check the test to see how high. I'm not about wasting your time. Be able to get it in factored form. Make sense? All right, because I definitely saw one of those on your homework. I don't know what they wanted. All right, this is super exciting and fun. This is the part of the homework that you will fly through. This is towards the middle, though, so don't give up when it gets hard. Keep going. Just write zeros of polynomial functions. Don't write with real. You aren't going to see any. You're not going to see any polynomials that says 5ix. Like, that's just weird. Just say zeros of polynomials. This is a fact. Imaginary, which we call complex, roots, and irrational, which are your square roots, We sometimes call those the in-betweeners, the ones you can see, but they give you the really nasty decimals, you know? So if you want to think of them that way. Always come in conjugate pairs. Okay, we got it down? Okay, while you're still writing, I'm going to explain to you the why of this. Okay, we found zeros of quadratics. Quadratics are the easiest polynomials, and we really kind of understood them pretty well. Okay, remember when you're solving quadratics, the best thing that you always hoped would happen would be it factored, right? If factored, you can find the zero super easy, it's fast. But if it didn't factor, there was only two choices that always worked, and the completing the square kids usually chose not. What was the method that always works the most? Quadratic formula for most kids, right? So that is the only way to find what we call the not nice answers, an imaginary, or one that would have an in-betweener with a square root of 2 or something, unless you had it in vertex form, okay? So what is a big part of that quadratic formula? X equals negative b plus or minus square root, right? Because of the plus or minus square root in the quadratic formula, every single time there's an imaginary number or a nasty square root, it's going to have a plus or minus in front of it. So what this means is if 2i is a 0, then what has to be a 0? Negative 2i must be. If 4 minus 5i is a 0, then 4 plus 5i must be. And if the square root of 2 was a 0, then negative root 2. If negative 2 minus 5 square root of 3 is a 0, negative 2 plus 5 square root of 3. Don't worry about the number in front because it's just the plus or minus square root part. Be careful with ones that look like this. I don't think it's going to show up, but I did read it in an explanation. The square root of 9. If the square root of 9 is a 0, is negative square root of 9 going to be a 0? No. Because if negative 9 was a 0, that actually means that 3 was a 0. And if you add 3 to something and subtract 3 from something, it's going to turn into a different number. Like, do you know what I mean? So be careful. Make sure it's only the ones that are actually irrational, not ones that would simplify out to be rational. Okay? Everyone got that? All right. So this will be very helpful on some problems. I did that and that at once. So here's an example you do not need to write down because it's just a little bit extra. They said, you have a polynomial, degree 6. So how many zeros am I looking for? I'm looking for 6. They are telling me 3 of the zeros. Here's a 0, here's a 0, and here's a 0. What are the other 3? It has to be the conjugate pairs, correct. If you see negative 2 plus 5i in your list of zeros and right beside it is not negative 2 minus 5i, you need to write it down, is what they're saying. If they only have one, you need to write the other. If negative 2i is a 0, then 2i has to be a 0. And if 1 minus root 3, then 1 plus root 3, and then that's 6, I'm done, right? But basically, we just talked about that, so I thought it was kind of a stupid one to write down. Okay, rational root theorem. Story with the rational root theorem is this. I think this is outdated because your calculator can do this. We do need to still talk about it, though, mostly because I keep asking Ms. Thurston and Ms. Kaptanovich if we actually really have to do this. I was like, yeah, you might as well. We just never know when it'll come up. I'm like, whatever. The story is this. The level of nerd of your teacher. The need for the rational root theorem. I am a dinosaur. I understand that. But I'm like the youngest dinosaur in the whole math department, actually. So, like, this hurt my feeling. Peyton, what's his, Bedorf, is that how I say it? Yeah, he hurt my feelings. So it's like, so think about this. Like, while like Mrs. Thurston, Mr. Reed are like those really old dinosaurs, I'm like a cute baby dinosaur from like Land Before Time. I go, he goes, Spike. I'm like, no, I'm not like freaking Spike from Land Before Time. That was like, he was like a stupid fat dinosaur. No, I'm like Ducky. The yep. Ducky was freaking cute. Do you know what I'm talking about? Who knows Ducky? Yes. Okay. So I appreciate that I'm a dinosaur, but I'm the young cute one. So first, remember that. Second, remember not all the time do people have graphing calculators. I had a graphing calculator, but it's because I asked for one for Christmas. Because even then, the same TI, does anybody have an 83 in here? Anybody have an 83? Some people do have an 83, usually about one per class. It still works, and it cost me $100. The ones today cost you $100. The technology has not changed. The only difference is they've like added color and a couple extra buttons here and there. I cannot believe how they haven't changed. But anyway, they would have some class sets and we would use them. Well, it used to be like I tell you, first graph it, find one on the table, divide it out. Well, what were you supposed to do if you couldn't graph it and find one on the table? Well, technically, we would have to randomly start guessing numbers, synthetically divide them out until we got one with a remainder of 0. So we would actually, a lot of times we would work in groups and be like, I'll try 1, 2, 3, 4, or something like that. Put it in the box. And then when somebody would get one in the class, we would yell it out so everybody could use it. Okay? Sad. I know. I was very popular in those days because of my calculator. Like everyone's like, oh man, she's got the coolest calculator in town, you know? I know. It brought me a lot of street cred, obviously. I went far with it. Became a math teacher. Anyway, so there are theorems that exist to shorten the random guessing. Okay? And that's called the rational roots theorem. What this theorem says is, if I should write it, if, because it might not even have any, if a polynomial has a rational root, it is on a list of possibilities found by plus or minus the factors of the constant divided by the factors of the leading coefficient. All of these problems on the homework you'll be able to do tonight. These are not hard. Nobody usually remembers that, so they just say P over Q. P is the end, Q is the beginning. Okay, so where did this come from first? Just 1 second for me to tell you where it came from. Let me write something down real quick. Okay, here we go. This is a good one, actually. All right, you don't have to write this. I'm just showing you where it came from. Okay, so let's say I asked you guys to factor 2x squared minus 13x minus 24. Are you guys good? Okay, you would hate it. These aren't enjoyable, right? I talked to you about the AC method, you remember? But originally we did the old guess and check, right? And when you guess and check to factor this, the only possibilities in the first spot are going to be what? 2x and x. Do you see where you have problems is with the 24? It could be 1 and 24, 2 and 12, 3 and 8, 4 and 6, right? Sucks. But those are always at the end. Okay, so I'm going to actually tell you what the answer is. It's plus 3 and it's minus 8. What are the zeros then? What is the zeros of this guy? One of them's easy. 8. And what's the other 0? Yes, it's negative 3 over 2, which came from solving that, setting that equal to 0 and solving. Okay, now this 8 I could put over 1. Does everybody understand that? P's come from the end, the 24. 8 and 3 are both factors of 24. Does everybody see it? Q's come from the beginning, which is the 2. 1 and 2 are both factors of this. So what this does is it allows me to have a shorter list. If I didn't know it factored and it's looking at something more complicated, I'm going to give you an example in a minute. Again, don't write this down. My possible list would be plus or minus all the possibilities of multiplying to get 24, which is 1, 2, 3, 4, 6, 8, 12, and 24. It's a long freaking list. All my possibilities for Q, because this would be P and this would be Q, are 1 and 2. So what this does is it doesn't help me a lot. This problem I would have hated as a student. But instead of using every number on the planet, I at least have it down to, well, all the P's over Q's, plus or minus. 1 over 1, which is 1. 1 over 2, 1 half. 2 over 1, 2. 2 over 2 is 1. I already did that. 3 over 1, 3. 3 over 2, 3 halves. 4 over 1, 4. Does everybody see what I'm doing here? 4 over 2, which is 2, I already have. 6 over 1 is 6. 6 over 2 is 3, already have it. 8 over 1 is 8. 8 over 2 is 4, already have it. 12 over 1. 12 over 2 is 6. 24 over 1. 24 over 2 is 12. So when I'm putting numbers in the boxes and synthetically divide, I shorten my infinitely number of choices down a little bit. It still sucks, but it has to be one of those. Does that make sense? Okay, so here's an example where you're going to do it. Most of them will be multiple choice, if not all of them. Just write this. Find possible rational roots. This problem would have been very fair as a math student for Mrs. Bruno. All of them would have been fair for me because I was a super nerd, but like for my friends who weren't as cool as me. To all the Spikes. Or Littlefoot. Yeah, somebody says, well, maybe you can be like Littlefoot. I'm like, Littlefoot has emotional problems and cries all the time. And they were like, yeah. I'm like, jerks? I'm like, a delicate fungus. Not a delicate flower, but like a fungus, because they're also delicate. Guys find any sheds yet? No? Anybody been looking? Shed hunting? I've heard they've been dropping. Somebody told me that. Have you found some already? Maybe this weekend. Shed. It's like, I said fungus, which made me think farm, which made me think. There are two things I like to do in the woods. I'm not a hunter. I love to find mushrooms. Like, love to go mushroom hunting. And it's actually the same to go shed hunting. It's just not as satisfying because it would have been, yes. The mushroom hunting is the best because usually you can come away with at least one or two. Right. You have you call them honey holes too? Does everyone call them honey holes? Well, it is like super exciting though. The most satisfying is when you find a new honey hole. That happened last year because my dad's property is relatively new. So one time I was just wanting exercise. So I wanted to walk up the hill instead of the trail. Plus I always think it's really kind of funny. Like I might die falling down the cliff whenever you get into, when you step right into mud, you know what I mean? Right. So I was like, oh, I'll go this way. And then I was like, oh my God. I was like, I was trapped between all these things, but there was like a million mushrooms right here. And I'm like, mushrooms. I was like The Hobbit. Anybody? No? No. Okay. Yeah. Super nerd. Hobbit alert. Okay. Okay. Are you guys ready? You got it down? So here's your P. Here's your Q. First of all, it has to be plus or minus, period. So on the multiple choice ones, one of them is not going to have plus or minus, and it's going to be wrong. Are you hearing what I'm saying? So make sure it's the plus or minus. I don't like to put plus or minus each time because that's extra for me, so I like to put it right in the front. But technically, each one of these numbers should have a plus or minus. How can I multiply to get 4? 1, 2, 4. How about 3? 1, 3. This is way easier than the last one, right? All of the P's over the Q's. So 1 over 1 is plus or minus 1. 1/3 is plus or minus 1/3, but I don't want to write it every single time. So 1/3. 2 over 1 is 2. 2 over 3 is 2/3. 4 over 1 is 4. 4 over 3 is 4/3. So Mrs. Bruno and her classmates, we probably could have found this relatively quickly, right? I do have 1, 2, 3, 4, 5, 6 to check. I don't remember for sure what would happen if you put the opposite. Like sometimes I think there was life hacks we were good at remembering, oh, if this came up, then usually it's the opposite one or something like this. But none of us would solve it this way. If I asked you to find the roots, what you guys would have done and what you should have done is immediately, you don't know how to factor this, do you? No, so you should type it in your calculator. 3x to the fourth minus 11x to the third plus 10x minus 4. Now, I'm telling you whatever we find is going to be on this list. Okay? So let's go ahead and type it in. And this is why they still want me to teach it to you, although it barely ever comes up, but I do have an example where it does. So, okay, I typed it in earlier. Do you need me to write the equation down again? It's y equals 3x to the fourth minus 11x to the third plus 10x minus 4. Okay, and when I graph it, how many zeros am I looking for, guys? 4. I'll tell you what happened to me when I did this problem yesterday. Is when I did the problem yesterday, I was excited when I looked at the graph because I'm like, sweet, I see 4. Some of you might only see 3, but I'm going to explain why I thought I saw 4. Here's one. Here's one, but I was a little worried about this one. Why was I worried about this one? Well, it's an in-betweener. Does everybody see it? And if I go back to my list of possible in-betweeners, my biggest in-betweener was 4/3. Does everybody see that? That's not 4/3. Does everybody? Well, what happened is, I'll explain it in a second. I thought this was a double root. Doesn't it look like a bounce? I thought that was a bounce, and I actually liked where that one was because it looked like it could be 1/3 or 2/3 or something. You know what I mean? One of those two. So I'm like, this looks like -1, and this has to be one of those. Well, this one then would have to be a square root. And a square root can't be by itself. So I was like, something is not right. So I sat here and I stewed about it for 10 minutes. No, none of the kids didn't give a rat's behind. But the math teacher is sitting here saying, why am I so stupid? Like, what is wrong? Well, when I zoom in, and I have to zoom in 3 times, still looks like a bounce. I I don't have, like, that's enough for me to tell. It's actually, oh, zoom. It's not a bounce at all. It's those are actually single roots right there and there. So one of those is on my list, and the other one is the square root friend of the one that's way out in BFE. Okay, that is not, no. What is, I need a new job. Like, what is wrong with me? Way out in nowhere. Okay, circle of trust, everybody. Circle of trust. Owen, are we good? Right. Am I good? Owen says we're good. I don't know. I'm sorry. Oh my God. Okay. So let's go to your table. Okay. Go to your table and you're looking for, well, we were looking for 4 because pretend I didn't show you all that. We were looking for 4 of them, right? And on my table, how many do I find? Okay. I found 1 at -1. If you just found 1 at -1, you should not be okay with that. For the reason I just told you, that means 3 are left. I can see there cannot be 3 that are square roots. So my rational root theorem, what it does is it says, hey, it's either at 1/3, 2/3, or 4/3. So you can change your table, and this is why they want me to still teach you this. If you go to table set, second window, and start it at 0 or 1 or whatever, and go down to change your table to table step, and make it go by 1/3. Now you'll be able to find another 0. Here it is. The other 0 is at 2/3. Does everybody see it? The 0.6 repeating. So those were the two nice ones, and the other two have to be square roots. Okay, so that's why we teach it. But always go to your calculator and look first. Now I feel like you don't need to do it, but sometimes there's decimals you don't recognize if you did second calculate 0. So that's why they want you to teach it. Okay, we're not gonna do that one. Okay, last thing, and you'll be able to do these on your homework tonight. These are very easy problems on the homework. Kids tend to forget it on the test, and they're easy points, and it's at the very end of the test, but kids don't remember it because it's not very important to them. And also, this is another outdated one. Okay, here's what it says. Yep. The number of possible real positive, this one's for positive, zeros, a polynomial, and we're going to name it P of X has, is the number of times the sign changes or that number minus 2 until you hit negatives. Okay, that might not make a lot of sense until we look at an example. We'll write the next part down as well. The number of possible the number of possible negative zeros is the number of sign changes of P of negative X. So you'll have to find that P of negative X first and then count the sign changes. And like I said, that's going to sound really funny until we do an example, and then you're going to think it's kind of easy. This one to me is more outdated than the other one, because the one thing you definitely can see if you have a graphing calculator is how many positive real times it crosses and how many negative real times it crosses. Like, it doesn't even matter what the values are. They're just telling you how many times positive or negative. So why would we do this? This helps you shrink your list further because there was plus or minus in front of all those things. If there were 0 possibilities of negative roots, then don't try the freaking negative numbers when you're dividing. If there were 2 possible, then you might have to start with the positives, because usually positives are easier to work with than negatives, stuff like that. Okay. So one example, and then we're going to look at a couple math lab problems. We're not going to have much time at all. But like I said, you're probably shooting for that 50% mark or so. Do what you can, or else jump ship and look at the review. Okay. We good? Here's the example. And the good news about these problems, is right in them, it'll say like use the rule of signs or use Descartes rule of signs. It'll say something like that, so you'll know to do it. I don't think you're going to want to write all that right now. So since you just wrote the rule, I would just write find possible number of positive zeros. Okay, so this is easy. Oh, you have to write the equation down too. So P of x is 2x to the fifth minus 5x to the squared minus 3x plus 6. So they're like, count how many times the sign changes. Well, what do I mean? I mean positive to negative or negative to positive. So look, positive to negative, oh, they changed. There's 1. Negative to negative, that does not change. Negative to positive does change. So there are 2 possible positive zeros. Possible. But don't forget, maybe they were both imaginary. So then we count downwards by 2. So subtract 2. There could be 2, but there also could be 0. So you have to write 2 and 0. There's no way going to be just 1. Does that make sense? So there's just going to be 2, or there's not going to be any. Now, to find negative 0 possibility, possible, I can't spell, possible number of negative zeros, you first have to do P of negative x. You can't do the exact same thing you just did, right? We already did that. So do P of negative x, which means plug in negative x. Okay, so I have 5 negatives being multiplied. That's still negative, right? So negative 2x to the fifth. That's positive, but then that's negative. So that's negative 5x squared. That's a plus 3x and a plus 6. So how many times did the sign change? Negative to negative, no change. Negative to positive, there's a change. Positive to positive, no change. So there's just one change. There's just one way that it could be negative. Subtract 2. Could you have negative? We don't do that's stupid. It's just 1. So what does this tell Mrs. Bruno's friends who were not nerdy enough to have their calculator? There is definitely a negative. Does everybody understand that? It says there has to be a negative. So when they're doing their synthetic division guessing, they would have been starting with the negative numbers. They don't want to waste their time with the positives because, yeah, there might be 2, but there also might be none, right? As soon as you find 1, it gets so much easier because maybe you're left with something you can factor. Okay, so you count the number of sign changes, and that's it, and then subtract 2 until you get to the negatives. Plug in the negative and do the same thing. You won't really ever use that ever in your life, except just to get the question right on the test. Count the number of sign changes. Okay? But they want me still to teach it to you, and I am a slave to the man. I just do what they tell me. Okay, we are going to look at Math Lab because a couple of the problems are, like I said, super tricky, but we're going to work so hard on it Thursday when I see you. What's the time, Sitch? What time do we? Perfect. I'm just going to probably just do one problem and then show you which ones that you need to do on your own. They said I needed to extend 4-3. Does that sound accurate? Even though that means if you don't have 4-3 done, that just means that Mrs. Bruno worked harder on her Algebra 3 homework than you guys, because I made a video because some kids told me that it was hard. I'm like, oh, that's sad. I don't want anything to be too hard for them. Let me make a video. So I do that nice thing And then I get emails from others that are like, hey, you need to grade my stuff. I'm like, can you just be nice? Maybe I could grade your stuff if I wasn't making these helping videos for you because I'm so helpful. I'll get it graded. Yep. I will. Okay. Oh, 4, 4. You do want 4, 3 extended? Does somebody in here want 4, 3 extended? Nobody? Speak now if you need 4, 3 extended. Okay, there she is. I'd say I'm shocked. I know, me neither. I was trying to be nice. Honesty is the best policy, though. You're right. Nicest is priceless, but okay, settings for class. All right, you're definitely going to want scratch paper. The problem I'm going to do with you. Okay. Question 1 and 2 were very much similar to examples we just did in class today. So those aren't going to be an issue for you. My computer is getting a little overwhelmed because I opened some more windows. What's the over under? We think it's going to open? There it goes. Anybody watch the fight this weekend? Yeah. Okay, so this one is very similar to the one we did, except they're giving you most of the spots, so you'll know if you're doing it right or not. They gave you the zeros. There's 3. They gave you 3. Write the factors and multiply. Write the factors and multiply, and you just have to find the missing piece. 2 is the same. And 3 is the one I want to talk to you about. 3 is weird and worth discussing. Okay, so is everyone looking at number 3? You're going to want to use your numbers and not my numbers. Battery low. Let's see if I make it. Okay, they want us the lowest degree polynomial, and they're telling me the zeros are 5 plus root 8, which I feel decent about because do you see what they tell me right away? 5 minus root 8. And remember, those have to come in pairs, and they did tell me both, so I'm good. And then they told me 1. So my list is complete, which means I'm already able to get rid of 1, actually 2 of the choices. Because they want the lowest degree, this list is complete. If they give me 3 zeros, what is the lowest degree it could possibly be? 3. So x to the 4th is out. Not only that, I told you that, yes, we could plug a 4 in front if we wanted to, but we're not going to choose to do that. So B is also out for me. Okay, now this is where the kids were confused. They're like, how do I write these as factors? Okay, x minus 1 is the obvious one. But how do I write these guys? Well, how did you go from 1 to this? You just took the opposite of it, right? The opposite of 1 is -1, and that's what you put there. So you're going to take the opposite of this. And the way you'll do it is you'll put x minus parentheses 5 plus square root of 8. Then the opposite of the next guy is x minus parentheses 5 minus square root of 8. And I'm not making a video of this, so all of you little gamer friends know that I hope you miss it. I know. Some things haven't changed since you were a sophomore. Okay. Now, I suggested that you multiply the conjugates together first. These two don't look like conjugates because they're both minus, but the original ones were conjugates. So they are conjugates, okay? So we are going to multiply these two first, but we're going to have to clean up a little bit first. And we're going to go ahead and distribute this negative. So it's x minus 5 minus square root of 8 for me. And you want to make sure you're using your numbers and not mine. And x minus 5 plus square root of 8. Okay, so I'm still committed to multiplying these last two. I'm going to have to triple distribute, okay? But remember what we know. We know if you get conjugate answers, things are going to drop out, and they really will. So prepare yourself for things dropping out. If you see something scary, know that it's going to drop out. So let's see what we got here. X times x. I'm good with that. That's x squared. X times minus 5 for me is minus 5x, and I'm okay with that. Here's the first thing I don't like. X times root 8. It's plus x root 8. And I'm hopeful that it's going to cancel. And if it doesn't, then I probably would stop that problem and wait until I saw Mrs. Bruno later and asked her what I was doing wrong. Okay? Done. The x is multiplied. Now let's move with the negative 5. Negative 5 times x. That's negative 5x. I'm actually going to put it underneath here for safekeeping because they're like terms. Negative 5 times negative 5, that's plus 25. I don't have any regular numbers yet, so I'll put that at the end of the list, plus 25. And negative 5 times root 8, I'm kind of getting worried because that's negative 5 root 8, and I don't have anything like that yet either. And I don't like it, so I hope it cancels out as well. Okay, move on to the last piece. Distribute the negative root 8. Here it comes. Negative root 8 times x. The x can go in front. That's negative x root 8. And I'm happy because those will be gone. Negative root 8 times negative 5 is plus 5 square root of 8. And that's the other thing I didn't like, and it is gone. The last part, some kids do have problems with. Negative root 8 times root 8 is definitely negative. But what is root 8 times root 8? Yeah, it is 8. Either think of it as root 8 squared, which cancels, or think of it as root 8 times root 8 is the square root of 64, which is 8. I don't know how your brains work, but that's just 8, which I could have put under the 25, I suppose. So minus 8 on the 25. All right. So now I have x minus 1 times, I have the x squared, minus 5x is minus 10x. And then 25 minus 8, is that 17? Okay, technically I can stop here because I already know what the answer is based on my choices. And the reason I know that is because the two things that are easiest to find are the first term and the last term when you're multiplying. It's definitely an x to the third. Those come from multiplying the first two pieces. The last one comes from multiplying the negative 1 times the 17, which is negative 17. So it has to be choice C for me. Okay. If I wanted to multiply them all out from here, I could, but I've done enough work to get the right answer at this point. Anybody planning on taking the ACT in February? I do have some practice math tests I thought I maybe gave you already. I'm curious if they allow you to change dates at all, or not change dates, change locations. Try to choose something in our region. I don't know if Lewis and Clark will still have it or if they'll cancel it because we're in a different phase or whatever. Okay. When I flip through these you can do, just make your factors and multiply 4, 5 is the one. 5 is the one that's degree 5. If they don't let you leave it in factored form, I would skip it. If they don't let you leave that in factored form, I would skip it. I know you can do number 6, even though it says degree 4. -2 is a 0 of multiplicity 3. 0 is a 0 of multiplicity 1. Just go ahead and multiply that all out. Just expand that x plus 2. And everybody's done listening to me, so it's fine. But you have just keep going. There'll be a bunch of hard ones in a row is what I'm telling you, and then they get easier again. Like, don't stop. Like, keep shopping. Try to get that 50% mark. Okay?